Hello, my name is Jack Heckenleibel. Today I'll be going over neural networks. So what is a neural network? According to IBM, a neural network is a machine learning program or model that makes decisions in a manner similar to the human brain by using processes that mimic the way biological neurons work together to identify phenomena, weigh options, and arrive at conclusions. They are a subset of machine learning and excel at image and speech recognition and language processing, specifically when trying to classify interpreted data. From a non-technical point of view, neural networks allow us to build computing systems that can adapt and improve from experience. The history of neural networks is relatively short compared to other newer technologies. However, that does not mean it is unrich in it. The beginning of neural networks started with Warren McCulloch and Walter Pitts, who introduced the first model of artificial neurons in 1944. 13 years later, Cornell psychologist Frank Rosenblatt created the first trainable neural network called the perceptron. Due to the lack of advanced hardware to power these neural networks, there were many challenges with them. It wasn't until the 80s that brought about a resurgence as researchers modified the weights and thresholds to allow more efficiency. And finally, computing hardware caught up with the theory of neural networks, which allowed for the boom we are seeing today. There are many different types of neural networks, but for time purposes, I'll be going over two. These are two of the most used neural networks right now: convolutional neural networks and recurrent neural networks. Starting with CNNs, they are primarily used for classification and specifically in image and video processing. CNNs are trained from three-dimensional data, which in most cases is matrices from images and frames. One major flaw that CNNs have is that they're computationally expensive. Moving on to RNNs, they are primarily used for natural language processing and speech recognition. This data is sequential and time series, so they are chronological. They're meant to be used for large language models. However, due to transformers and a vanishing and exploding gradient problem, they are losing popularity. Deep learning is a subset of neural networks, as it is a stack of multiple layers inside a neural network. Deep learning has been the main reason why we now have self-driving cars, real-time language translation, and facial recognition. The depth and complexity of these networks has contributed to a significant amount of societal progress and advancement. Now I'll be going over the applications of neural networks, and I will begin with healthcare. At first, I could not think of how neural networks could help in the doctor's office. However, with just a single Google search, it became abundantly clear how much it does. For starters, neural networks can identify cancer in images that doctors struggle with. Also, deep learning models have helped predict disease progression through examining health records. These are just two examples that have clearly helped the medical field make more accurate diagnoses and improve patient care. In the financial sector, neural networks have been used for fraud detection, algorithmic trading, and credit scoring. Fraud and identity theft have cost billions of dollars, and not every bank employee can catch small difference in spending. Neural networks have been able to spot unusual patterns in purchases quicker and more effectively. Investing has taken off with the easy access to market trading and information across the internet. Machine learning algorithms, specifically neural networks, have shown promise in predicting stock direction based off the history of the stock and the social context behind it. While neural networks have powerful capabilities, they have several limitations. First, they are prone to data overfitting and bias. When the model is too complex for the data, then it can lead to overfitting. And when the data is clean and has prejudice, the model can have biases. One of the largest challenges with neural networks is that they operate as black boxes. When they predict data, they can't explain why they came to that conclusion. Neural networks operate patterns and adjust to said patterns, and do not fit reason on how they got their result. Neural networks have transformed computing by enabling systems to learn and adapt from experience. Despite previous challenges, there seems to be a constant drive to innovate neural networks so they advance in all fields. The potential is limitless. Just as the human brain can achieve so much, artificial neural networks can do so as well. Here are my references.